right, this is lesson number 2. Our learning target is I can compare functions based on their rates of change and y-intercepts. So functions can be represented by a table, a graph, equations, or words. You can compare two functions represented in different forms by comparing their y-intercepts, and their rate of change. Which you may also know as slope, which should be a familiar word from when we did linear equations. So let's take a look at an example. A zebra's main predator is a lion. Lions can run at a speed of 53 feet per second over short distances. The graph below shows the speed of a zebra. Compare their speeds. To compare their speeds, compare their rate of change. So a lion, it says what their speed is, 53 feet per second. So a lion is 53 feet per second. That is their speed. And for a zebra, we just have to find the rate of change here. Now, we know that this is a proportional graph because it starts at the origin and it makes a straight line. So I'm going to look at this point right here, which tells me that a zebra can travel 59 feet per second. So 59 feet per second. And I can grab that because this is a proportional graph. So I can grab the unit rate when x equals 1. So since 59 is greater than 53, therefore the zebra can run faster over short distances. All right, let's go on to the next page. A certain car has a mileage of 22 miles per gallon. The gas mileage of a certain sport utility vehicle, or SUV, is represented by the function shown. Compare their gas mileage. So for the car, it says right in the problem that it is 22 miles per gallon. So I'm going to write down 22 miles per gallon. And for the SUV, since this is a proportional graph, and I know that because it's a straight line through the origin, I can just grab this point here, which tells me the unit rate is 19. So that is 19 miles per gallon. (22) is greater than 19. Therefore, the car can drive more miles on a tank of gas and has better mileage. The car can drive more miles on one tank of gas and has better mileage. All right, next one. The function m equals 140h, where m is the miles traveled in h hours, represents the speed of the first Japanese high-speed train. The speed of a high-speed train operating today in China is shown in the table below. Assume the relationship between the two quantities is linear. Compare the functions y-intercepts and rates of change or slope. So for the Japanese train, we were told this equation right here, which is miles is 140 per hour. The slope here is the coefficient of the h, so the slope here is 140 miles per hour. The y-intercept is whatever is added onto the equation. In this case, nothing is added on, or is 0, so the y-intercept is 0. For the rate of change, I know that this is going up by 1 each time. And if I look right here, this is going up by 217 each time. So the rate of change is 217. It did not tell me what the value was at 0. So I'm going to say in 0 hours, and if I subtract 217, I get 0. So the y-intercept must be 0. If you ride each train for 5 hours, how far will you travel on each train? Well, this one goes 140 miles per hour for 5 hours. If I multiply, I would get 700. So you would get 700 miles of distance traveled. We found out it's 217 miles an hour, and for 5 hours, you would get 1,085 miles. All right, next page. The number of new movies a store receives can be represented by the function m equals 7w plus 2, where m represents the number of movies and w represents the number of weeks. The number of games the store receives is shown in the table. Compare the functions y-intercepts and rates of change. In other words, compare their y-intercepts and their slopes. So for y-intercepts, movies, they said m equals 7w plus 2, and the y-intercept is whatever is being added or subtracted on, in this case a positive 2. For games, find the number of games at week 0. So if it was week 0, since all of these are adding 3, I'm going to take away 3 and I get 0. So at week 0, the y-intercept is 0. Now we're going to find the rates of change. So movies is 7w plus 2. This is the slope or the rate of change. So they get 7 new movies a week. And for games, since we're going up by 3 each time we found the pattern in the table, they get 3 new games per week. The rate of change is greater for the movies. How many new movies and games will there be in week 6? Well, for movies, we're going to use movies equals 7w plus 2. And we're told it's week 6, so we're going to plug in w equals 6. So for movies, the equation is 7w plus 2. We know that 6 weeks are going to pass by, so 7 times 6, and then we're going to add on 2. 7 times 6 is 42. 42 plus 2 is 44. So 44 movies in 6 weeks. Now for games, we're going to extend the pattern in the table for week 6. So going up here, so if 4 weeks go by, let's add 3, there's going to be 12 games. 5 weeks go by, add 3, 15 games. 6 weeks go by, add 3, 18 games. So there'll be 18 games after 6 weeks. Next one. Of the 3 linear functions represented below, which is the greatest rate of change? So let's find each of their slopes or rate of change. Here, the rate of change is the coefficient on the x, so m equals 2. Here, I'm going to find a pattern. So these are going up by 1. So to find the rate of change, I'm going to see what happens here. Up by 6, up by 6, up by 6. So here, the rate of change is 6. A number y is 2 less than half of a number x. 2 less than, which means we're going to switch the order, half a number x. So half a number x, but I want 2 less than that. So m here is a half. So which is the greatest rate of change? Function 2. Okay, next page. Anna's mother needs to rent a truck to move some furniture. The cost to rent a truck from 2 different companies is shown in the table and graph. Which company should she use to rent the truck for 40 miles? So which company should she use for 40 miles? So first, we have Crosstown Movers, it's a graph, and we have Ron's Rentals, which is a table. Use 2 points to find the slope, and then use the slope and y-intercept to write the equation. Now here, guys, this is not a proportional relationship. And I can tell because this graph, although it's a straight line, does not go through the origin. So we're going to review how to use the slope formula. The slope formula is y2 minus y1 divided by x2 minus x1. So let's make this x1, y1, and x2, y2. So this is going to be 45 minus 35 all over 30 minus 10, which is 45 minus 35 is 10, 30 minus 10 is 20, and that simplifies to be a half. So I know m equals a half. I also know that the y-intercept is where the function intercepts the y-axis, which is at 30. So I know b equals 30. So the equation of the line is y equals a half x plus 30. Now we are going to let x equal 40 and use the equation to find the cost of 40 miles. So I know that we want to travel 40 miles, and I'm going to plug that in for x. So y equals a half times 40 plus 30. A half of 40 is 20, so y equals 20 plus 30. This is going to cost $50. All right, going to the other table for Ron's rentals, we are going to extend the table to find out the cost for 40 miles. So each time here, the miles go up by 10. So I'm going to have it go up by 10 to find 40 miles. Over here, the cost goes up by 25. So I'm going to add $25 on to find the cost for 40 miles, and I get $100. So the cost is $100. So if the cost of Ron's rentals is $100 and the cost of Crosstown Movers is $50, I would choose Crosstown Movers. Crosstown Movers because they have a lower cost for 40 miles.